Welcome to Geek Do-It-Yourself Mechanic. This video is the third video of a three-part video series to discuss concepts that can help you properly test an automotive analog sensor circuit. This particular video will address pull-down type circuits. Let's review part 1. It discussed how to properly backprobe the sensor, testing powers and grounds, and testing that the sensor works correctly. For this video, we're going to assume there is some sort of error. For example, the scan tool is not displaying a different value even when we cause the sensor to change state. For example, pushing on the accelerator pedal since we're working with the throttle position sensor. In part 1, we demonstrated how to test the sensor. This video will discuss how to test the PCM sensing circuit when it's configured in a pull-down design. I've watched numerous Scanner Danner videos and have even interacted with Paul via video comments about some of the concepts about to be presented to you. Our goal is to test the analog sensor line to the PCM voltage sensing circuit. Let's navigate to our demonstration circuit. Knowledge, electronics, testing concepts. 3-wire sensor. We need to do two things for this video. I need to configure the PCM in a pull-down configuration, and I need to disconnect the sensor. There we go. We've disconnected the sensor and configured the PCM sensor circuit in a pull-down configuration. Since the sensing circuit is configured in a pull-down design, the voltage sensing circuit reads 0 volts, and that's what the PCM, remember down here, displays what the PCM is reading. This is because there is no current flow, which allows the pull-down resistor to bring down the voltage to ground. Test A. 5 volts to sensing. Due to the circuit's configuration, the PCM senses 0 volts. Therefore, connecting 5-volt reference to the PCM sensor wire brings the PCM sense to 5 volts. Let's do that real quick so you can see that. And it does. 5 volts is being read by the PCM. Therefore, the scan tool should now read 5 volts. If this occurs, you have just verified the sensor line to the PCM is good and the voltage sensing circuit in the PCM is functioning properly. Again, we verified this line is good and the sensing part of the PCM is working. But let's pretend that the PCM sensor wire is somehow being ground. An example would be a hole in the insulation that is touching the frame or ground. (5 amps). Once I connect the sensor line to ground, did you notice the current? I did. Look how fast those circles are flying through there. We just shorted the PCM's 5-volt reference circuit. Not good. It is probably protected, but still extremely dangerous. Don't do this. Instead, whenever applying the 5-volt reference to the PCM sensor line, use a resistor as a jumper. Scanner Danner suggests using a 5K resistor. This is because most sensors are about 5K of resistance. Therefore, the circuit is tuned for that. Let me show you how the circuit behaves differently when jumped with a resistor versus a wire. Right now this is a wire. Let's put in a resistor. Using this technique, you can perform the same test but in a safe fashion. This allows you to determine if there is a short between the PCM side sensor and the PCM. If the scan tool still reads 0, and it does, because remember I have a short right here, that shouldn't be there. This is simulating a short to ground. You have a short in the PCM sensing line, or the voltage sensing circuit in the PCM is failing. In this case, we know there's a short to ground here. So if I remove this, it's behaving as we would hope when the sensing line is good. It's 5 volts. "5-volt reference to PCM ground." Taking the 5-volt reference to the PCM ground tests nothing, causes a short to ground, and shouldn't be done. So please read your wiring diagrams carefully. If you notice, when I connected this, the current reading, very high, 5 amps. We just took down the PCM's 5-volt reference circuit to ground. Not good. The PCM's 5-volt circuit is probably protected, but this is extremely dangerous. Don't do this. So let's not. Test 3. Ground to sensing. Since we're in a pull-down design, taking the PCM voltage sense circuit to ground doesn't test anything. I'll show you. Ground to ground is ground. Sort of like dust to dust. Nothing will occur since we're connecting ground to ground. Let's run some tests using a test light. The first 3 tests will be performed with the test light connected to battery positive. If you remember, these down here represent test lights. This one is the test light connected to battery positive. This test light is connected to the ground or chassis. Test 1. Positive test light to 5-volt reference. If you feel uneasy already, you should. Why? The test light's connected to 12 volts, and you're connecting it to the 5-volt reference line. Applying 12-volt test light to the 5-volt reference line could cause damage. In my humble opinion, this could cause unpredicted results since the circuit's response to this is dependent on the 5-volt reference circuit design. What I'm trying to say is that the 5-volt reference circuit is connected to sensors that either pull up towards 5 volts or pull down toward 5 volts. And since you could have raised it to 12 volts, you could cause some issues and unpredictable results. In any case, don't do this. In addition, this test makes no logical sense, so let's not do it. Test 2. Positive test light to ground. Applying the test light to the connector ground, turns on the light and ensures that the connection truly connects to ground in some fashion. So we've just verified this whole line to the PCM is good. As you see, current's flowing, meaning the light would be on. Test 3. Positive test light to signal line. Applying test light to voltage signal line makes the PCM register 12 volts. Yet the scan tool will probably still display 5 volts since the software limits the value to 5 volts for display, most likely. Again, the reason we have to say most likely is it depends on how the designers of the PCM wrote their code. Because it could be the voltage sensing circuit that chops it at 5 volts, or it could be the software that clips it at 5 volts. In theory, since the voltage sensing circuit draws very little current, this test should be safe. Scanner Danner does this test all the time. Again, this test demonstrated that this sensing line and the voltage sensing circuit worked, because if you remember, when it was disconnected in the pull-down configuration, it was a ground. So this verified circuit's integrity. The following 3 tests will be performed with the test light connected to battery negative, chassis or ground. Test 1. Negative test light to 5 volt reference. Applying the test light to 5 volt reference turned on the light. As you can see here, current is flowing, and it's only 125 milliamps. The current draw should be very low and not cause any issues. But if I wanted to verify the 5 volt reference circuit, I would use a DVM or scope. I would want to use my scope because I want to make sure that voltage is clean and stable and straight and constant at 5 volts. Where turning on a light, you may not perceive if it's pulsing or if there's noise in the line. But this allows you to do a quick test nonetheless. Test 2. Negative test light to ground. Applying the test light to the connector ground does nothing since ground is being connected to ground. This particular test accomplishes nothing. Test 3. Negative test light to signal line. Applying the test light to the signal line doesn't change what the PCM registers. The scan tool will continue to display 0. Again, that's because we're in a pull-down resistor configuration. It was already at 0. So taking a ground to ground is ground. This concludes our tests for the pull-down sensor design. I invite you to visit this page and play with this circuit as well. Perhaps try testing the circuit and see what happens. Again, you should always avoid allowing current to go straight to ground without going through a load first. When this occurs, it is referred to as a short or short to ground. For more information on this topic, please refer to the suggested readings. Thank you for watching. I hope you found the information helpful.